One of the reasons for the success of CUDA as a platform is that the tools are actually pretty good. So in this module, I'll show you the tools that we'll be using to write, debug, and profile CUDA programs. So CUDA is supported on Windows, Mac OS, and many varieties of Linux, and the choice of tools depends on the operating system that you're interested in using for development. In this course, I'll be primarily using Microsoft Windows and Microsoft Visual Studio and the corresponding CUDA toolkit and Nsight installation. Also, I'm going to focus on desktop GPUs, even though the mobile GPU space is equally exciting nowadays. So the first piece of the puzzle is the CUDA toolkit. The CUDA toolkit basically contains all that you need to compile and run apps on CUDA. It includes, first of all, an LLVM-based compiler that is used to compile CUDA C applications. In fact, NVIDIA also ships a compiler SDK for adding CUDA support to your favorite language. Then there are various libraries that CUDA ships with. This includes not just the headers for the core math functionality like sine and cos, but more complicated mathematical constructs such as special functions, random number generators, fast Fourier transform, and so on. The CUDA toolkit comes with extensive documentation. There's a large set of PDF files that you can basically read like books. Also, there are plenty of samples and even a sample browser that lets you fire up examples of different CUDA features. And then there is Nsight. Nsight is essentially a different thing on different platforms. So on Windows, Nsight is a plugin for Visual Studio, and on other operating systems, Nsight is a whole IDE that's built on the Eclipse platform. Either way, Nsight is the only convenient way to debug something on the GPU. So if you did get Nsight as part of the toolkit, I recommend you go and download it. Needless to say, all these tools are available free of charge, though Nsight might require you to join a special program and actually get approval from NVIDIA. And this also applies to the various mobile development programs as well. As I said already, I'm not going to cover any extra platforms and toolsets in this course. We'll just stick to Visual Studio and good old-fashioned desktop GPUs. If you go off to the NVIDIA website and download Nsight for Visual Studio, the following is a good illustration of what you'll actually get in the package. So first of all, there is Nsight for Visual Studio, currently supporting 2008 and 2010, but not yet supporting 2012. That's basically the plugin that lets you browse devices, fire up CUDA debugging, as well as perform graphics debugging, which we don't really care so much about. Then there is the Nsight Monitor. This little thing is basically a service that monitors your connection to a CUDA-capable device. It also provides a little pop-up window that shows up in the Windows taskbar to let you know the status of the Nsight service. Then there is the C++ AMP debugger, which we're not going to cover here because strictly speaking, AMP is a competitor technology to CUDA. And finally, the CUDA toolkit that comes with the compiler, the libraries, and the project templates to let you actually write CUDA-capable apps. So in the last module, I was talking about how GPUs are commodity products because everyone has them. Well, when it comes to business-grade GPUs, things get a little bit more difficult because those things are actually more expensive. So if you've got lots of developers, it really doesn't make much economic sense to buy each of them a very expensive GPU. The only exception being if they're maybe game developers. So Nsight solves this problem rather elegantly by positioning itself as a client-server architecture. And the idea is very simple. You basically have a server which has the GPU that you want to run your code on. The server sits somewhere, it doesn't really matter where. The only thing that matters is that you have the Nsight service running on that machine. And then you've got the clients. And these are basically just machines that have Visual Studio and the Nsight plugin installed. And these machines are used for development, and when they need to do some GPU profiling, they can simply connect to the Nsight service on the server and run their code, debug it, profile it, anything else they need. And maybe I'm making it sound a bit too simple, and in fact there are a few issues with this sort of model. Nsight is only good for GPU debugging, so if you need to debug CPU code remotely, you need to go back to the good old Visual Studio remote debugging, and we all know how painful that can be. And of course, since you are executing code remotely, you'll need to figure out your own mechanism for actually accessing the output of your application. That said, if you were working with a GPU cluster, for instance, you'd have exactly the same problem.